Hello guys, welcome. As I said yesterday, today we were going to talk a little bit about the geologic column. So geologic column is actually a tool that scientists and geologists use to kind of figure out the relative ages of rock layers or fossils. To make their jobs easier, what geologists do is that they combine data from all over the world from undisturbed rock sequences. And from this information, they can create the geologic column. So geologic column is literally like an ideal sequence of rock layers that contains all the known fossils and rock formations on the Earth. And of course, it is arranged from the oldest to the youngest. And by relying on the geologic column, scientists can kind of interpret the rock sequences. So when they're looking at a particular rock sequence, a particular rock layer, they can compare it to the geologic column and kind of figure out what layer it is or what time it was formed. And they can also use this to identify layers in puzzling rock sequences. For example, if the rock layers were upside down for some reason, this is how they would figure it out to understand what exactly happened or which layer goes where and where it was formed, and so on. Now, this is an example of a geologic column. If you look here, this is also arranged from the oldest to the youngest. And you can see the different types of rock layers, and you can see distinguished lines here that tell you, for example, it says 80 million years old. Or here it says 82 million years old. And if you go to a little bit downward, you will say over here it says 94 million years old. So this is an example of a geologic column, and here you can see different types of rock layers, and geologists can compare whatever they found with these layers to kind of figure out how old certain rock layers are, or what kind of fossils should be in there. And so on. Now, how rock layers become undisturbed? Now, we heard that in a lot of cases, rock layers are undisturbed, as in they are just left alone. But sometimes what happens is rock layers get disturbed. They are not left in the same position in which they were formed, right? And we're going to look at four scenarios as to how rock layers can become disturbed. Now, the very first one is a fault. A fault is basically a break in the Earth's crust along which the blocks of crust slide relatively to one another. Now, if you look over here, this is a picture of what fault would look like. So what happened here was there was some break in Earth's crust, and blocks of crust kind of slide relative to one another, and they kind of form these layers. So this is a fault. On the other hand, you can see rocks can become disturbed because of an intrusion. Now, if you look over here in this picture, you can see that this is a rock layer right here, right? Rock layer A, right? But you can see that rock layer A is kind of intruding upon rock layer C and rock layer B, right? So this is an intrusion. An intrusion is basically when molten rocks from the Earth's interior squeezes into existing rocks and cools down. And when it cools down, it kind of gets set into place and it becomes an intrusion. So we are assuming that this is a molten rock layer. And what happened was that it squeezed itself into these rock layers and it cooled down. And when it cooled down, it got set into place and became an intrusion. We also have folding, which is when rock layers bend and buckle from Earth's internal forces. Now, if you look here, you can see that the rock layers are literally folding. They are in a very unique shape. And when you see rock layers in this shape, you can assume that this happened due to the Earth's internal forces. Rocks basically bended and they buckled and formed this shape. folding, if there's folding, you would generally see them in this shape. And finally, there's tilting. Tilting, as literally the word means, tilting is when internal forces in the earth slant the rock layers. So typically, the rock layer should not be in a slanting position, or they should not be tilted. But if it is, it probably happened due to the Earth's internal forces. Now, if you look at the picture here, you can see that the rock layers are very much tilted when you compare to the surface of the Earth, very much tilted. And if tilting had not happened, this would not be in this position. They would be completely horizontal. But since this happened, we can assume that Earth's forces have to do something with it, and that's how these became to look like this. Now, disturbed rock layers. Geologists often find features that cut across existing rock layers. And the relationship between rock layers and the features that cut across them can actually be used to assign relative ages to features and the layers. So how that works is that features are younger than rock layers because we assume that rock layers had to be present before the features could actually cut across them. For example, let's go back to, when we go back to the slide, not this one. So hold on. So there was some problem because of which I couldn't record properly. So if you hear me repeating stuff, that's probably why. Let's see. So when we go back to this one, the intrusion, right? So we have to assume that these rock layers were actually present before this intrusion took place. That's what we are learning about. So we are assuming that this rock layer was present and is older than this intrusion. This intrusion possibly could not have taken place if this was older and the rock layers had formed around them. It will look completely different if that was the case. But we are assuming that this rock layer was present, it's older, and then molten rock kind of squeezed itself into the rock layer B and formed the intrusion. So we are assuming that the intrusion is younger than the rock layer B, right? So that's what we're saying here, where we know that the features are younger than the rock layers because the rock layers had to be present before the features could actually cut across them. Events that disturbed rock layers. Now, geologists assume that the way sediments are deposited to form rock layers, which is in horizontal layers, it has not changed over time. So, according to this principle, if the layers are not horizontal, something must have disturbed them before they were formed, right? For example, here, you can see that the layers are not exactly horizontal, they're tilted, right? So we must assume that something probably disturbed them, and in this case, it was the Earth's internal forces, right? So if it's not horizontal, there must have something that actually had an effect and changed how they were formed. Now, this principle actually allows geologists to determine the relative ages of rocks and the events that disturb them. And for example, let's look at folding and tilting. We know that these events are always younger than the rock layers they affect, because if they were not younger, then we would have no way to know if the intrusion took place, because if the intrusion had to take place, it must be younger for it to happen when compared to rock layer B. And that is all we're going to talk about. I hope you guys had a good time, and I will see you later.